Every week, there's a new phrase that makes you feel late.
Overlap. Prompt engineering, vibe coding, loop engineering. It never really stops.
Yeah, it really doesn't. But there's one new term that actually changes everything.
Absolutely.
Welcome to the deep dive. We are incredibly glad you're here with us today.
Yeah, thanks for joining us.
Most of us are still using AI the very messy way. We just dump a massive question into one long, chaotic chat.
Right.
We just cross our fingers. We just hope for a perfect answer.
Which is wild.
It is incredibly risky, especially when product decisions are on the line. Customer code shouldn't rely on a single, unverified dice roll.
Exactly. That single chat box is a massive gamble for your business. You're basically treating a complex system like a magic 8-ball. We have passed through a few different eras of AI use already. First, there was the era of prompt engineering.
Right.
That basically meant asking the AI much better questions.
You just tweaked the words to get a slightly better result. You added phrases like, think step by step, to the prompt.
Yeah, exactly. Then we moved into the era of context engineering.
Giving it more background.
Right. That meant giving the AI better information to work with. You uploaded PDFs or, pasted in long documents. But now we have finally arrived at graph engineering.
Which is the big one.
It is. This means you actually design the structural work around the AI.
You build a system instead of just typing a sentence. You design a workflow that manages how the AI operates.
Exactly. Most people are still caught in the one big question trap.
Yeah.
They ask a model, should I build this new startup idea? Then they let one single AI instance do all the heavy lifting.
It researches the market, it runs the pitch, then it judges its own confidence.
Right. It grades its own homework based on its own initial assumptions.
Wow.
That is just way too much trust in one single answer. It is deeply dangerous for your code base and your customers.
I have to be honest here. I still wrestle with prompt drift myself.
Oh, sure.
I just dump everything into one giant text box. Then I just pray the model remembers my original instructions.
Yeah.
By prompt 5, the AI has completely forgotten prompt 1.
We all fall into that trap because it feels incredibly fast.
Yeah.
It's kind of the path of least resistance for most daily tasks.
It feels like asking a guy in a garage to build a car.
Right.
You just hope he gets every single part right from memory.
Yeah. Good luck with that.
But graph engineering is a completely different mental model entirely. It's like building a fully automated Ford assembly line.
And on a real assembly line, every station has one specific job. That is the core concept of the multi-agent alternative. You break the massive task into much smaller, manageable jobs.
Right.
You get a planner agent to map out the initial steps.
Yeah.
You get a customer researcher to read through forum complaints.
You also need a skeptic agent to challenge the weak ideas.
Exactly. A merger agent then brings all those isolated pieces back together.
Yeah.
Finally, the workflow demands a human stamp of approval.
Before we go any further, let's define some important jargon here.
Sure.
What exactly do we mean when we say a graph?
Well, a graph is simply distinct jobs connected by directional arrows.
Okay.
But practically, it operates as a rigid state machine.
It freezes the workflow until a specific condition is met. Simple enough. And what exactly does the term state mean here?
State is just what the overall system knows so far.
Got it.
It is the memory passed from one node to the next.
Right. And just a quick note for you listening today, we mean agent graphs that actually move digital work along. We are not talking about knowledge graphs that just connect information.
Exactly. Agent graphs actually execute tasks based on the current state.
Why is it so dangerous to let the AI do it all in one pass?
Well, an isolated model will always confirm its own initial bias. It lacks an independent mechanism to challenge its own core assumptions.
So one model shouldn't write the answer and grade itself.
Bingo.
Now that we understand the assembly line concept, we need a blueprint.
Right.
Let's think about the actual structure of this automated work. If we are building a factory, what shape should the line take?
Good question.
I imagine a linear sequence, just handing a baton down the line.
Well, a straight line works fine for very simple, predictable things.
Okay.
But the most efficient layout for complex work is the diamond pattern.
The diamond pattern.
Yeah. It is the fundamental anatomy of a truly good graph.
A diamond shape. Beat. Walk me through how that actually functions.
You always start at the top with one single clear question.
Right.
Then the workflow widens out into parallel work lanes.
Okay.
Multiple agents tackle different pieces of the problem simultaneously. After they finish, the graph narrows down to a checker agent.
Then a merged answer forms at the bottom point.
Yes. And Finally, the work hits the crucial human approval gate.
One question, parallel work, a checker, merged answer, human approval.
That's the diamond.
Let's ground this in a real example from our research sources.
Yeah.
There is a case study about building a Shopify bookkeeping product. Let's say I want to know if I should launch this.
Well, the messy way is just asking Claude that entire question once. You might get a very confident, very generic business plan back.
Which is useless.
It's completely useless for actually making a real financial decision.
But the graph way applies that diamond pattern we just discussed.
Exactly.
The planner agent breaks the massive task down first. It identifies that we need to understand pricing, distribution, and risks.
Then the workflow widens out to those parallel researcher agents.
Okay.
One agent exclusively studies Shopify merchant pain points on Reddit. Another agent looks at the API documentation for existing accounting tools. A third agent analyzes search volume demand for bookkeeping solutions.
They do not wait for each other to finish their work.
Right.
But hold on a second. I need to push back on this. Doesn't this level of rigor completely kill the speed advantage of AI?
It's a fair question.
If I have 5 agents running, aren't I just waiting longer?
It might seem that way at first glance, but parallel processing actually makes deep research incredibly fast.
Well...
Yeah, you make concurrent API calls to the model simultaneously.
Oh, because they are literally running at the exact same time.
Exactly. You get 5 deep research reports in the time it takes to run one.
Wow.
Then the diamond shape begins to narrow down again.
Right.
The Skeptic agent steps in to review the parallel research.
It aggressively attacks the weak claims in the research documents.
Yeah, it looks for outdated evidence or completely missing competitor analysis. It finds places where customer pain gets confused with willingness to pay.
That is a crucial distinction for any new startup idea.
Absolutely. After the Skeptic finishes its review, the merger agent takes over. It synthesizes the surviving data and creates one clear recommendation.
It tells you to pursue, pause, or kill the idea entirely.
Right. All before you spend a single dime on software development.
Then comes the human gate, where you make the final call.
Exactly.
Do I need to build a diamond graph every time I open Claude?
No, only when the work involves multiple steps, sources, or high risks.
Okay.
Simple tasks just don't need this kind of heavy machinery.
Got it. Skip the graph for brainstorming. Use it for deck research.
That's a great rule of thumb.
So we know the diamond shape works beautifully for complex problems.
It really does.
But how do we actually build one without getting totally overwhelmed?
Yeah, that's the hurdle.
Most people freeze when they see complex technical orchestration tools.
You absolutely must start at level 1.
Level 1.
This is the manual lanes approach.
You literally draw the entire workflow out first.
Yes. Open Excalidraw or a completely blank text document.
Okay.
Put the ideal final outcome at the very top of the page.
Then you map out the separate, distinct jobs below it.
Exactly. You create a customer research lane. You create a competitor analysis lane. You create a dedicated checker lane. Then you run the entire process completely manually yourself.
That sounds almost too simple to actually work in practice.
Well, it is entirely essential for your long-term success.
Really?
If the manual workflow doesn't significantly improve your final output, automation is useless. It will only help you create average work much faster.
Ite. That is a very sobering thought for most builders.
It's the truth, though.
Level 1 makes sense for visualizing the initial process, but I can't run a software business on Excalidraw whiteboards forever.
No, definitely not.
What exactly happens when we move to Level 2?
Level 2 introduces the file-based workflow.
Okay.
You use tools like Claude Code or a local Claude repository. The goal is to create a distinct paper trail of the work.
Instead of one massive chat history, you create separate markdown files.
Exactly.
I'm guessing this acts as a sort of external memory.
It completely solves the dreaded context window problem.
Right.
You make a plan.md file for the initial strategy.
Okay.
The AI reads that file, does work, and creates a customer.md file.
Oh, I see.
The next agent only reads the customer file to do its specific job.
It essentially passes the baton through the local file system. Yeah, I can see exactly what happened at each step of the process. And you can reuse the exact same folder structure next week.
It gives you incredible consistency without requiring heavy software.
That makes a lot of sense.
Finally, you earn the right to reach level 3.
The big leagues.
This is where the complex orchestration tools actually come into play.
We're talking about frameworks like LangGraph and AutoGen here.
Yeah, exactly. LangGraph is great when you need rigid state checkpoints in memory.
Okay.
AutoGen works beautifully for directed workflows with parallel conversational steps.
And you use tools like N8N or Make for your CRM and Slack integrations.
Exactly. But there is a massive, crucial rule you must follow here.
Which is?
Only automate after doing it manually 3 full times.
3 full times?
Never break that rule under any circumstances whatsoever.
Right.
The specific tool always comes after the proven workflow.
Jumping straight to level 3 orchestration tools feels like a huge mistake.
It is.
It's like buying a $5,000 treadmill before you've even proven you'll go for a walk.
You just end up hanging your dirty laundry on it.
Yeah, exactly.
When you automate a workflow you don't actually understand, you just get a faster mess.
Technical debt builds up from the very first day.
Absolutely.
A mess with way more moving parts to constantly debug.
Yeah.
Exactly. When do I earn the right to use the fancy orchestration tools?
Only after you run the workflow manually at least 3 times.
Yeah.
You must understand every single input and output perfectly first.
Test the workflow 3 times manually before touching automation tools.
That is the absolute golden rule of graph engineering.
So what does this all mean for real business operations? Let's look at how this functions in the wild.
Customer support is a perfect place to start analyzing this.
Okay.
It is not just having AI answer the raw support ticket.
That is way too broad and incredibly risky for a brand.
Yeah, the real effective workflow is much more nuanced.
Mm-hmm.
First, a classification agent determines the exact type of issue. Then, a different agent checks the user's specific customer account.
Another agent searches the internal documentation for the current policy.
Exactly.
Yeah.
Then a drafting agent writes the initial reply.
Okay.
But then comes the most important part of the entire graph.
Yeah.
A separate agent is forced to review the business risk.
It specifically checks for refund policies and legal tone.
Yeah, it checks for unauthorized account changes or dealing with angry customers.
Right.
Only after it passes all that does it go to human approval.
That is infinitely safer than letting a chatbot reply directly.
Oh, without a doubt.
What about something more creative, like organic content creation?
It follows a very similar structured graph pattern.
Really?
Yeah. One agent researches the trending topic. Another agent forms a unique thesis. Another agent finds relevant historical examples.
An agent writes the hook and drafts the main script.
Right. Then the critical checker agent steps into the flow.
Okay.
It asks, are the examples actually specific? Does the pacing work? Does this sound human or robotic?
After that, it branches into generating titles, thumbnails, and B-roll suggestions.
Exactly.
Here's where it gets really interesting, though. Let's talk about coding.
Coding is where graph engineering becomes absolutely vital for survival.
Wait, I need to really push back here.
Sure.
Isn't writing the code the whole point of tools like Cursor?
Well, sort of.
I mean, I can just hit tab and it auto-completes the entire function. Why do I need 5 agents to do what one good autocomplete does?
Because generating a block of syntax is only a tiny fraction of software.
Okay.
Just because code compiles doesn't mean it integrates safely into production.
That's fair.
A real coding graph has one agent plan the feature architecture first. Another agent actually edits the code in an isolated sandbox environment.
Then a totally separate agent reviews the differences line by line.
Exactly. Another agent spins up a container and runs the integration tests.
Wow.
A different agent checks how the changes affect the user interface.
Yeah.
You even have an agent that deliberately hunts for obscure edge cases.
And then finally, a human approves the actual pull request.
Right. Quality no longer depends on someone remembering the perfect prompt.
The structure of the graph guarantees the quality of the output. Why is that review risk step so critical in the customer support graph?
Because AI models love to hallucinate wild refund promises or adopt bad tones.
Ah, right.
A dedicated risk check prevents those mistakes from ever reaching the customer.
It prevents the AI from making wild promises or legal mistakes.
It keeps your entire business out of serious legal trouble.
We are almost ready to actually try this ourselves.
Yeah, that's exciting.
But we need to know where the hidden traps are waiting.
The biggest pitfall is adding too many agents way too fast.
People probably assume more agents must just mean better thinking.
Yeah, but it actually creates endless, confusing coordination loops. You might get 5 AI workers just repeating the exact same weak idea.
They just use slightly different wording to agree with each other.
Exactly. The system spends more time coordinating than actually thinking deeply.
The absolute goal is the smallest graph that demonstrably improves quality.
That's the secret.
What is the ultimate payoff for getting this architectural shift right?
Deep context becomes your ultimate defensible business mode.
Right.
Graphs leave behind incredible notes, evidence, and clear decisions for next time.
It gives your company memory, not just a fleeting one-off output.
Every research graph creates much better customer notes. Every content graph creates deeper, more nuanced audience insights.
Every support graph creates better product feedback loops. 2-sec silence. Whoa! Imagine scaling that.
It's powerful.
All that context building a memory that makes every future workflow smarter, the system actually learns and compounding value is created.
It stops being a neat chatbot and becomes a real operating system.
Let's talk about executing the very first rep. Give us the exact step-by-step process.
Step 1 is crucial. Pick one weekly workflow you already run with AI today.
Step 3. Write the ideal final output in one single, clear sentence.
Step 3. List the jobs a great human would do to accomplish this.
Step 4. Draw arrows only where one specific step depends on another.
Step 5. Add one human gate right before the most expensive decision.
And Step 6. Run it completely manually once before automating anything.
You got it.
Speaking of that human gate, how strict should it actually be?
Keep it very light and fast for private notes or internal research.
Okay.
But you must make it extremely strict for public posts or code deploys.
Stricter for processing refunds or touching production data, obviously.
Exactly.
What's the worst-case scenario if I skip the human gate on a coding or support graph?
You risk deploying untested code that breaks your entire production database.
Ouch.
Or you send out hallucinated policies causing massive financial and reputational damage.
Without a human gate, expensive mistakes happen on autopilot.
That is the scary, hidden reality of moving too fast.
This whole concept forces a massive mental shift.
It really does.
You stop asking, what is the perfect prompt I should use?
Overlap, and you finally start asking, what is the right workflow for this?
Yeah. You stop prompting, and you start actively managing systems.
That is the true essence of graph engineering. You give each piece the right context, check the weak parts, and keep absolute control.
Think about a daily task you completely trust AI with right now. What would happen if a Skeptic agent was forced to review it before you ever saw the output? What hidden blind spots might it uncover in your daily routine?
It is a profound question that completely changes how you view your own work.
Grab a blank piece of paper this week, draw some directional arrows, build your very first manual graph.
Have fun building.
Thank you for joining us on this deep dive.